Alright, here's the mini mill all set up finally with the X, Y, and Z axes all hooked up using quick connects here. And then we have the main on switch, power supply on the left, and driver board on the right. Gotten it all calibrated to the correct amount of steps per inch, and I have some practice foam on there. And we have a little arm here that holds the LCD monitor, and what I've done is I am going to cut out of this foam hopefully a pocket that this bearing will fit right into. It should be right about exact flush, and the diameter should be exact. So and I'll just clamp it down with my hand. I have, this bearing is roughly 0.45 inches thick. I have it set to plunge down into the material 0.25 inches at a time. So basically it's going to make that loop twice. Let's see. The first one it'll cut out 0.25, and then the next cut it will cut out the balance of the material. So first of all we want to zero, I was going to use that, you can steal it. Zero out the X and zero out the Y. Oh, we're in reset. Get the motors going, 0, 0. And then we'll jog the axis down. And we'll call that 0.0. Looks pretty close anyway. So, there we go. And then we'll jog it back up so I can get I can hold on to it with my hand, and we need to turn it on, turn the spindle on. There we go. Alright, now we're ready to run the program, so we'll hit cycle start. And we'll hold it down with our hand, and there we go. Watch it cut up there, cutting out the spiral, getting rid of all the inside material. The second pass for the finished depth of cut. Spiral back out to the outside. Program should be there right at right where we started there at the very tip top. So what we'll go ahead and do now is jog that axis out of the way, and then we'll dump this out in the foam out in the trash can, try to anyway. Oh, look at that, a hole. And now we'll determine whether or not this bearing fits in that hole. Ta-da! Perfect fit. Styrofoam makes the perfect test bed. And I actually designed that in the wizards. You can pick the wizard so you don't actually have to draw anything. You can just click circular pocket and you enter in all the information. We'll go to it real quick. You enter in all the information: pocket diameter, center point, your rapid clearance height, your tool diameter, blah blah blah, depth, step depth, that's what we had set at 0.25, that's why it took 2 passes. Final depth, so that's how you do it in with the tutorial, or with the whatever you call it, the wizard. So that's it in a nutshell. If you want to get more complicated, you can draw the part in something like SolidWorks and then post-process it. I've been using SheetCam. So if you wanted it, that would do something like if you're wanting to do a bolt circle around here, or something a little more exotic than just pocketing a bearing. But there's no way to do that by hand with just a cutting bit. There's no way to do that. So it's pretty cool. And there's the step back and you can see the overview of the whole thing. There's the whole machine. There's a Y-axis stepper motor, X-axis stepper motor, and Z-axis, or up and down vertical stepping. All those are ball screws with oversized ball nuts in them, Ronton ball nuts for almost zero backlash. It's very close. And then we can turn on backlash compensation in Mach 3 itself to help control that. And that's just a cheapo depot Chinese stepper board, but it works pretty well. These are microphone type plugins, microphone type connects, and then the power switch to control the power to the actual board itself. So pretty simple. Pretty simple. Pretty hard to actually make though. So, something that's a little different. This is a direct drive. This is different than the design most folks use. Come around to this side. This is a direct drive to the head. There's no pulley reduction. The only downside to that is there's almost zero clearance. It's probably 1/8 of an inch clearance between these two motors, but they do clear each other, so all's well there. But that's about it. Now I'm going to put some way covers on here. I have those, I just haven't put them on yet. That'll keep the foam off these or the aluminum off the ball nuts when you're machining aluminum or something like that, so you don't wear them all out. But all in all, it looks pretty good, and I think we'll hopefully be able to make some cool stuff.